Hey everybody, this is Michael Parent from Michael Parent Consulting Services. Today I wanted to talk about a very important topic, one that I like to talk a lot about, which is measurement system analysis. You might have stepped on a bathroom scale recently and you didn't like the numbers you saw, so you got back off and stepped on again expecting a different number. And sometimes you will in fact get different numbers when you step on the bathroom scale. Now, you're not changing, you're weighing the exact same, but the measurement that's being reported out is actually varying. And this is something that we call the measurement system variation. And it doesn't just exist in bathroom scales, but it exists in every single thing we measure. Is that what we're reporting is a representation of the actual process and the variation that we might say piece between parts that's actually occurring, but we also are capturing some sort of measurement variation, whether it be that bathroom scale that varies maybe by a couple pounds, maybe by a half pound, or even something as robust and precise as a laser. There's still variations in these. And what happens is we get kind of this additive function, right, where we're capturing the process variation, we're capturing the measurement variation, and then we're reporting, and most importantly, we're making decisions on our result, which is both of these variations. And this can be very costly to businesses and manufacturing facilities, because if we're making decisions on reported data that have excessive measurement variation, we could be making the wrong decisions. So one of the things we do when we are doing continuous improvement, when we're doing a Six Sigma process or process improvement project, is we want to validate to make sure that the measurement system is varying within the tolerance of what we're looking at between parts. This is really important, not just for making decisions, but also protecting customers. So if we have a downstream inspection process at the end of our production facility, and it's measuring something, but it's measuring something with so much variation that we really can't even protect the customer from a bad part going out the door, then we put ourselves at risk. We put, safety of our customer at risk. All of these things. It's actually something that I've experienced while working in the tire industry. These are bead vents over here on the right. And what these bead vents can do is if they get excessively long, they will actually slowly deflate the tire. They sit right here where that tire meets the wheel, and little by little air can escape if these things are too long, and they don't get a good seal of the tire on the wheel. And then over time, that puts the customer at risk, and they don't really like to see a flat tire when it's a brand new tire, right? They have to go to the auto shop, they have to reseat the wheel, they probably scrap out the wheel because it's not holding air and they don't know why. And all of this affects your position in the marketplace, and it affects the direct material costs for field failures. So what we want to do, and in this case, we were just using a ruler. This is the standard operating procedure, is this ruler. And between operators, what we saw is that operator to operator, or even looking at the same operator, taking the same measurement, there was not repeatability or reproducibility in this process, which meant that we weren't able to make sure that this tire was meeting the customer specifications before it was getting sent out the factory door. So very, very significant impact this had on the production facility. Now, if we go to this report that I have built, is we look at this thing for our measurement system analysis called Gauge R&R. The R, as I just mentioned, stand for repeatability and reproducibility. Let's say that again, repeatability and reproducibility. Repeatability is agreement within the operator. So what I have here is some data, and I'm looking at an operator who took a measurement of some widget, and then they took, and we've got 10 different widgets here, and then they took another sample of those same widgets. And what we're hoping is that they agree. If I step on the bathroom scale the first time and I step on the bathroom scale the second time, they should agree because nothing has changed. And this is what we see more or less to be true. And then we do the same thing with the second operator, where we're looking for internal agreement within the operator. That's the repeatability portion. But now we're also looking at the reproducibility. What's the difference between these operators, right? Is operator one biased in any way, either lower or higher than operator two? Another way of thinking about this is, if you step on the bathroom scale and it tells you that you're 165 pounds, and then you step on another bathroom scale and it tells you you're 160 pounds. Well, one of those is biased one way or the other. Either one is reading too heavy or one is reading too light. And to understand that difference is going to help us improve our measurement system and help us make better decisions. So this is kind of the data portion of it. We collect the data, we run some trials, and then what we do is we create a gauge R&R report. And there's three facets in this that are really, really important. The first one is the average measurement, which really shows how much for each part everyone agreed. In this case, we see that on average, each of these parts varied between the parts, right? Part number 4 had less than, say, part number 7. Maybe it was weight. I'm not sure exactly what we were measuring in this widget. But we can also see that there's agreement between the operators. Both operator 1 and operator 2 are measuring very, very close to the same thing. We see the only difference is really on part number 7, where operator 2 measured it much higher than operator 1. So we would say on average that this has a very good reproducibility. The measurement system has good reproducibility. We also want to see the repeatability. So we take the difference between each of those trials, and we see on average there was only one instance where operator 1 measured differently between trials. So this we would say is probably pretty good repeatability. Repeatability is the ability to reproduce the results within the same operator, right? Operator 1. And then most importantly here is we're looking at the percent of variation. So as we go back to that first sheet, right, we have a tolerance. We want to capture all of the actual process variation, and that way we can report that. So we have kind of this tolerance to say measurement is going to vary, but I want it to vary relatively small relative to my actual process. And that's what we look at in the report. We say on average that if it's less than 20% of what we've measured, then that is suitable, that's acceptable process variation in the measurement system. If it's greater than 20 but less than 30, we say it's not great, but we can probably live with it. But if it's if it's greater than 30%, so if 30% of the reported variation is coming from just bad measurement, then I can't really act on that, right? I can't make good business decisions. I probably can't protect the customer. If you are in food manufacturing or something, you probably aren't getting your recipe right. You might be trying to put a pound of sugar into a recipe, but you're actually putting a pound and a third of sugar because your measurement system is off by 30%. These have huge consequences for costs and for product quality. So if we ever see any of these things, the total gauge R&R greater than 20%, that beckons us to try to improve the measurement system. What we do hope to see is that this part-to-part variation is very high. If this part-to-part variation is high, what it's saying is great, our measurement system, all of the variation is actually coming by looking at different part measurements, which is exactly what we want to do. So in conclusion, this is really an important aspect of any improvement project, really any operations management course, is you want to understand that your output of what you're actually making business decisions on is not just the process itself or the product characteristics itself, but it's also a function of the way we measure as well.